All right. For example one, and let's pull this back, see if we can see more of the image. Okay, so I took the graph in example one and made it bigger. And this is included in the assignment. So you can play with this larger graph if you wish. So first we want to, I'm not, this is example two, pardonnez-moi. Here we go. First we want to find the limit as x approaches to from the right of f of x. Let's see. We're approaching -2 or +2? -2. Okay, so we're going toward x equals -2, and we're looking at the values of the function that correspond to these x values. So we're here. Do you see that if you substitute in any of the x values in this arrow, you will get f of x values that go up? So the limit as x approaches -2 from the right of f of x, it goes to positive infinity. So we don't really say equals, goes to positive infinity. Infinity isn't a number, so we wouldn't say equals infinity. Okay, well, let's look at the limit as x approaches -2 from the left. So we're here, we're looking at x values smaller than -2, and we're plugging those x values into the function. So here we go. And I can see that the closer I get to -2, the larger the f of x values will be. So similar to the other, the limit as x approaches -2 from the left of f of x goes to positive infinity. But we have one further thing. We want to find f of -2. And normally when there's an asymptote, like there is here, this dashed vertical line means this is an asymptote. Then the function would not be defined at the value. But do you see that it's been pasted? They've pasted the value. Let's see, what is this point? The x value is -2. The y value is 2. So at x equals -2, we get +2. Now we can answer the questions. Does the limit as x approaches -2 of f of x exist? It's kind of weird with infinity. Some people say that yes, it exists and goes to infinity. And that's pretty much what we'll have to agree with, because that's what the textbook says. But if you don't like that, it's okay. You don't have to believe that. So this is really cool stuff. We're getting into the place of belief. So according to our textbook, the limit as x approaches -2 with no plus or minus of f of x goes to positive infinity. So that's the first part. And then, is f continuous at x equals -2? We're just going to use the finger test. If I'm tracing along below x equals -2, in order to get to the other part of the graph, I have to jump. So it is not continuous. And you can see that it isn't, but I want you to have a physical reaction as well. So not continuous at x equals -2. Is there anything else we had to do for that part? Okay, good. And I do want you to find all three values for each part of this question. So for the try this, you'll have to find the limit as x approaches -4 from above of f of x, the limit as x approaches -4 from below of f of x, and the value of f of -4, and then answer the questions that follow. And likewise for parts B and C. It's the same graph. I repeated it so that you can draw on it. There's also a big one included. All right, part B. We want to find the limit as x approaches +2 from the right of f of x. Okay, let's. So here's +2. And if I'm looking at f of x values that correspond to these x values, then I'm on this part of the graph. So as x gets close to +2 from the left side, from values of x smaller than 2, the function gets close to 5. So we would say that the limit as x approaches 2 from below, from the left of f of x is 5. So I did the second thing first. I found the limit as x goes to 2 from below of f of x. So let's see, what color? Oh, purple. I don't think I have a purple. Golly darn. I have to get some better markers. Now we're looking at the limit as x approaches 2 from the right side, or from values of x larger than 2. And the part of the function that corresponds to these x values, right here. And I can see that as x values get closer and closer to 2, the function values get closer and closer to 3. So I would say that the limit as x approaches 2 from the right, or from above, of f of x is equal to 3. But we have one other value that we need to find. What is f of 2? So let's look. If we're looking at the part of the function that corresponds to values of x smaller than 2, there's there's a circle. So that's not a defined place. If we look at the part of the function corresponding to values of x greater than 2, we also get to an open. So, oh, here it is. So f of 2 is equal to 4. Physically, I can see that if I trace my finger along the function as we get close to 2, I've got to jump and jump again in order to get from one part of the function to the next and to the next. So this is not continuous. At x equals 2, and the limit from the left and the limit from the right are different. So since the limit as x approaches 2 from the left is not the same as the limit as x approaches 2 from the right or from above, the limit as x approaches 2 does not exist. And we would write that the limit as x approaches 2 with no plus or minus of f of x does not exist. So I think we answered all of the questions for part B. Let's check it out. Does the limit exist? We said no. Is it continuous at 2? We said no. The next value, or the next x value we want to look at is x equals 4. Okay, groovy. Let's look at x equals 4. So let's see. Okay, I certainly hope that I just paused it and unpaused it because I needed a fresh piece of paper. So now we're looking at values of x approaching 4. So here's 4. I want to plug in x values that get close to 4 using values that are smaller than 4. And the part of the function this corresponds with is right here. This little curve, and it starts to go up. When we get closer and closer to 4, from using values of x smaller than 4, I can see that we get close to the y value 5. So I would say that the limit as x approaches 4 from below of f of x is equal to 5. What about the limit as x approaches 4 from the left, from the right? I think I'm saying the wrong words. Left, negative, positive, right, above with the plus, below with the minus. So let's see. Let's substitute in values of x larger than 4, going smaller and smaller toward 4. So these are the x values we're plugging in. And it looks like the only part that really it's going to matter to us is values of x smaller than 5, larger than 4. And that corresponds to function values that are getting closer and closer to the y value 5. So I would say that the limit as x approaches 4 from above of f of x is also equal to 5. Hey, that's kind of groovy. What about f of 4? So here's 4, and it's filled in. There's an actual value. So I can see that f of 4 equals 5. So several really groovy things here. The limit exists because from the left and from the right, we approach the y value 5. So the limit exists. And equals 5. Furthermore, the function value is 5. And when that happens, when f of c is equal to the limit as x approaches c from the right, pardon me, from the left, and that equals the limit as x approaches c from the right, left, right. When this happens, when the function value and the two parts of the limit all are the same value, then the function is continuous at x equals 4. So there are three parts for continuity. The limit from the left has to be the same as the limit from the right, and those two pieces have to be the same as the function value. So the limit can exist without the function value being well behaved or even defined. But in order for continuity to exist, the function has to have the same value as the limit. And we can see just by tracing our finger that if I'm looking at the part of the graph that contains f of 4, right here is f of 4, I don't have to pick my finger up. I can see that it is definitely continuous.